Welcome to the explainer. Let's just jump right in. Imagine you're building a mobile app, and this app needs to do something incredibly common, like uploading user photos directly to an Amazon S3 bucket. A fundamental question pops up right away. How does the app actually log in to AWS? Well, if your very first instinct is to grab an IAM user's permanent access key and hardcode it right into the mobile code, you are walking straight into a massive trap. Seriously. Because a hacker will simply reverse engineer your app, rip out that permanent key, and potentially hold your entire cloud account for ransom. So how do modern, highly secure applications actually log in? Well, the reality is they bypass traditional passwords entirely. Instead of relying on static, permanent keys that can be stolen once and abused forever, modern cloud architectures rely completely on temporary, self-destructing credentials. And this brings us to a brilliantly simple core mechanism of cloud security. Now, when a human logs into an AWS console, sure, they use a password or maybe a biometric login. But when an application, a server, or a CI/CD pipeline needs to talk to AWS programmatically, it uses something totally different. Behind the scenes, it relies on the AWS Security Token Service, which we usually just call STS. Let me show you exactly how this dynamic authentication works. To really wrap your head around STS, think about it like this. Imagine you're visiting a highly secure government building. When you arrive at the front door, they absolutely do not just hand you the master key to the building. That would be insane. Instead, you walk up to the front desk and you show your ID. After verifying exactly who you are, they print you a temporary visitor badge. Now, this badge has strict limits. It might only work for the third floor, and at exactly 5 p.m., the barcode on that badge automatically deactivates. Even if you walk outside and drop that badge right on the street, it is completely useless to whoever picks it up. That secure visitor badge process, that is exactly what STS does for your cloud applications. STS essentially acts as that front desk security guard. It issues short-lived security credentials that are generated dynamically right on the fly. And even more importantly, they automatically expire the second their time is up. Let's break down the exact step-by-step execution flow of how your application requests and receives that temporary badge. First, your application makes an API call to STS using a very specific command called AssumeRole. Basically, the application raises its hand and says, hey, here is who I am, and I want to temporarily assume the specific IAM role to do my job. Next, STS checks to verify if the application is actually authorized to wear that hat. Finally, if it is approved, STS hands back a temporary credential package. But this is where you really need to pay close attention, because this is not your standard login package. STS gives you exactly 3 things: an access key ID, a secret access key, and a session token. To make any successful API call to AWS going forward, your application absolutely must pass all 3 of these strings together. Think about that for a second, because these credentials have a strict built-in expiration time, which can be anywhere from just 15 minutes up to 12 hours. You completely eliminate the nightmare of secret rotation. You don't have to write and maintain complex, fragile scripts just to cycle out old passwords. The system inherently cleans up after itself. Now, what's really fascinating here is how STS acts as the ultimate bridge between entirely different systems. Because once you understand that STS issues temporary trust, a whole world of secure architecture suddenly opens up to you. Let's look at a real-world deployment pipeline to see this in action. Say you're using GitHub Actions to deploy infrastructure to AWS. The old, incredibly dangerous way to do this was to create an IAM user, generate a permanent access key, and save that key permanently inside GitHub as a secret. If GitHub ever gets compromised, or say a developer accidentally exposes that secret, your entire AWS account gets hacked. But the modern secure way, that involves configuring GitHub to request temporary credentials from STS dynamically. Your pipeline gets exactly what it needs for that brief 5-minute deployment, and then the keys just vanish into thin air. Or consider federated login for a massive enterprise. If your company uses Microsoft Active Directory, your employees do not need separate AWS passwords. They simply log into their standard corporate portal. Behind the scenes, their identity provider talks to STS, and STS essentially trades their verified corporate login for an AWS session token. It's totally seamless, passwordless access. And this exact same concept brilliantly handles cross-account access. Let's say your monitoring app in account A needs to read some critical logs located over in account B. You do not copy passwords or duplicate permanent keys across those accounts. Instead, you simply grant the app in account A the permission to execute an AssumeRole API call against a specific, highly restricted role in account B. But this is where people mess up. And honestly, it happens all the time. In fact, this is a massive trap designed specifically to catch you off guard on the AWS Certified Developer or DVA-C02 exam. Developers will test their code locally on their laptops using their own long-term IAM user credentials. And locally, it works perfectly. But then, they push that exact same code up to a Lambda function or an EC2 instance that relies on STS, and suddenly the application crashes. Every single API call fails with a really frustrating authentication error. So why does this happen? Well, because when they wrote their custom API requests locally, they only passed the access key and the secret key. They completely forgot the third piece of the puzzle, the session token. Remember, when you use STS, the session token is absolutely mandatory. Without it, AWS instantly rejects the request. There's also another major hurdle you need to watch out for, and that is the permissions trap. The absolutely crucial point here is understanding how your identity shifts. Imagine your application already has a set of basic permissions. You write code to call AssumeRole so the app can briefly access a highly restricted database. A lot of developers think their app now has its original baseline permissions, plus the new database permissions. That is entirely wrong. When you assume a role, you completely drop your original identity. You do not add permissions, you replace them. Your app can now only do exactly what that new temporary role explicitly allows and absolutely nothing else. All right, let's lock this down before we finish. Here are the 3 rapid takeaways you absolutely need to remember. Number 1, modern AWS applications authenticate using the Security Token Service to generate temporary, automatically expiring credentials. Number 2, temporary credentials always consist of an access key, a secret key, and a strictly required session token. And number 3, the AssumeRole API call is the primary mechanism for granting secure, cross-account, or federated access, all without ever hard-coding permanent keys. Which brings us to our final slide, and a very important warning. Never try to build your own custom credential caching and rotation logic in your application code. It is dangerous and, quite frankly, unnecessary. If you're using the official AWS SDKs, they automatically handle the STS requests. They seamlessly attach the session tokens to every single call, and they silently refresh those credentials behind the scenes right before they expire. So let the SDK do the heavy lifting. Which leaves us with one final thought to consider as we wrap up this explainer. If your current cloud infrastructure still relies on static passwords or permanent access keys just sitting in a configuration file, how many ticking time bombs are currently hiding in your code?